test session. I will share my screen. Okay, so can you see my screen?
Yes, sir.
Yes, sir.
Okay, so let's create a new drawing. So today we are going to start steel building, industrial steel building. So let's start for the modeling. So how first of all you need to fix your geometry of the building. Geometry means your footprint. Okay, so number of columns, number of bays. Okay, for example I will just explain on paint. Yes, so if you want or if you have design but you need to create the 3D model and 2D drawings, so you need to fix first the number of rows and number of columns. Okay, suppose I have used, suppose this is grid 1, this is grid 2, then 3, then 4, right? So these are grid, then this is the horizontal grid A B C D. So you need to fix first what is the dimension, grid to grid dimension. Okay, what is the your requirement, right? So on the basis of that you need to design your I section column. Okay, the size of this column, then you need to design the rafter size. Then if your span is long, so you need to add here wind column. Okay, so in the wind column if you add, so in future I want to add here roller shutter here. Okay, so this is the industrial building for access any truck or any vehicle or any gantry girder. So all those part you need to add here roller shutter. So on the basis of that you need to fix this distance. Okay, then after that all those criteria, so there is some plinth here, chemical plinth means some pump or some chemical tank is situated here, so you need to give here plinth or any trench location. So if your purpose is creating this structure for storage the chemical or any fluid, okay, and if the fluid is filled here floor, so you need to give the access for drain out. Okay, so all those things you need to consider while you are doing the designing. Okay, so let's start. So just consider we need to add here 3 meters grid to grid, the distance here 3 meter, then you can give here 4 meter. If I want to add some roller shutter, so roller shutter is maximum or standard size is 3 meter or 3.5 meters, so you can go with that 4 meter, then here 3 meter. So all those door roller shutter and lower sizes, so before designing you should know or you should aware of the sizes. Okay, so on the basis of that you need to design or you need to planning. Okay, so let's start. So I will use, yeah, so I will take this structural analysis default metric, click here open, click here OK. Okay, so this is the new drawing, and before start work I will save this file, save as a project. Okay, you need to give your respective folder location, desktop, Rabbit training 310, and I will give the name here test 3, or you can give any name as per your requirement. So most of we are given the name for this file as our structure name. So if your structure name is suppose polymer dosing building or uh, any structure name, so you can give as a name for this file. Okay, so I will just make it save. Okay, then if you are working with multidiscipline, okay, so this project is multidisciplinary project. So I will explain. Yeah, so this is your structural drawing. Okay, and after that mechanical is also working on that, on this folder, then after that electrical also working on that, right? So you need to coordinate all discipline. So suppose if you design this pad, okay, or suppose plinth, and on this plinth is resting some tank here. Okay, So before you start the designing this size of this plinth, okay, so you need to receive some inputs. So weight of tank or any criteria for this tank, diameter of tank, volume of tank. So on the basis of that, you need to find out this thickness and sizes. Okay, so once you model in your structural drawing, so this mechanical discipline also use your model, structural model. So what he did, so he will excerpt your model. Okay, so once he excerpt in your structural model, it looks like so. This is so this plane comes as a xrep. Okay, in this mechanical model, and then after that he can just add the tank on this. So he is working on all mechanical part. Similarly, we will xrep this mechanical drawing. So this mechanical as a xrep in our drawing, and we can just create our structural drawing here. Then similarly electrical also. So electrical also xrep both the drawings, or both the xrep, both the model as a xrep, and then he can just add it their electrical conduits, all other things. For this coordination purpose, you need to set your model at one point, so that if mechanical is xrep your model, it comes at the right location. If electrical is xrep your model, is comes right location. So what we'll need to do, so you need to set your point. You can, so you can say the survey point or project point here. So if you open your Revit window, so and if you on this point, so you can see this point. So this point is your x equal to 0 or y equal to 0, and z you can give any level. X means your x, then y location, and then z is your third dimension. Okay, so you need to set this. So what we are doing, so we need to fix this. So this point is our 0 comma 0 comma 0. So you need to fix. So suppose my geometry or my grid is like that. Okay, so I want to fix at any location. So you can set here or here. Okay, so if you set here x equal to y equal to 0, so your model is lock at this location. So if the mechanical is xrep your model by uh, by shear coordinate, so it's comes exactly at this location. So your model, structural model and mechanical model, if all disciplines set this set their individual model, okay, at this location x y equal to z equal to 0 at between the grid 1 and a intersection between the grid 1 and a. Okay, so so all disciplines should one set the one project point here. So how to set the project point, let's see. So you can see we are not able to see any project point because they it has been off here. So you need to on here. So how to on, just type vv, right, and go to the annotation category, sorry, model category. And if you find site, so you can see this is the site. So this is the untig here, right? So I want to tick here site, and if I click on this plus symbol, so you need to click this point also, project point and survey point. Okay, project base point, and if I apply here and okay, so you can see like that. So this point is your origin. Okay, so you need to fix your model at this location. Okay, so generally what we are doing as per the standard. So if your, this is your building, okay, and this is your wall, like that. Okay, so we are generally set this point, lower lower bottom. Okay, lower bottom. So in case what happen, if I model this building with 200 thick wall thickness, okay, and if I fix this, and after that if I want to change this thickness, so I can change, but my point is fixed here. Okay, so this thickness is increase outside, so my point is not disturbed. So generally we are giving the survey sorry, project point is your lower bottom, internal corner of the wall at the lower bottom. But in our case we are just starting this grid, so you can give any as per requirement. So I want to give here because this point is my fixed point. Okay, if I want to add one more grid, so I can't give the left bottom. Okay, but this point should be same for all discipline. Okay, so let's start. So if you go to the architectural and click here grid. Okay, so as per the standard vertical grid it should be ABC, and horizontal grid it should be numerical as per client standard, so you can just follow. So right now I will just add here. This is my grid A, and you need to fix this our grid to grid distance. So suppose I want to copy this grid by 3 meters. So I want to add here wind column. Then after that I want to copy again 4 meter. So this is my span. Then I want to copy again meter. Okay. Then after that you need to create a horizontal wave. But you need to suppose if you have 4 way. Okay. 1 2 3 and 4. So you need to give the grid number here, right? So I will just add grid here, grid number 1. Then suppose my bed horizontal distance is just 4 meter. Okay, this span, so you can see. Then I want to copy again by 4 meter. Then I want to copy again 4 meter. Okay, then you need to select all. Okay, so if you select here, then you can see this project point also select. So you have option here. Once you select, you need to go here in filter. So just click here filter, so you can see what which element you have select here. But I want to select only grids. Okay, so I will untick this option, project base point and survey point, and click here apply and okay. And I want to give the move command mv. Okay, and select this as a base point and paste here on this point, project base point. So this is my project base point. What happened? Okay, not paste exactly at here. Okay, what I do, I will just add a line here first and just for taking the reference. Then I want to select all again, go to the filter. Okay, I will unselect this survey point and base point, project point, and click here apply. Okay, and just go here, and you can just unselect this line also. So press shift and just select. Okay, and just give the move command. Okay, I will select again, go to the filter, project base point, survey base point. Okay, and give the move command, and you can just right click, go to here snap override, and you can select here endpoint. So endpoint of these lines. Yes, so you can just delete this. Okay, if you check this coordinate, so if you go here annotation and click here spot coordinates, and if you measure this one, so you can see this is north equal to, north means your x and east is your y. So both are equal to 0, right? These are the levels. Okay, so you can see I have added this. So I want, if I cut the section, so we know the plan, and this is my section. So I want to just add a one raft. So just consider this is the 500 thickness. Then I want to add the column here. Then I want to give the rafter here like that. So whatever this give you can give here. So this is my ground level, right? And this is my top of column here, and you can give the roof here. So suppose if your this distance is 800 so you can just add the one level for roof, so that we can, if you working on 2D drawing, so you can use this level. Okay, so let's start. So okay, so this is my ground level. So I will just add here ground level. Okay, but suppose as per your site condition, if your ground level is just above, so you can give what will say at the whatever you have received. Suppose if your ground level is 90.00, you can give here, so your ground level will be changed, right? So you need to give accurate ground level, whatever as per your requirement. Okay, so if I measure this, so this is the gap is 3 meter, right? And if your ground level is 300 above the ground level, so you can just add 300 and you can just start your work. Okay, so you should give your actual level. Okay, so right now my actual top of ground is 0, I have just consider. But if you receive some different level, so you should give actual level. So on the basis of that, you need to add all levels. Right? Then you need to find out this column height. Okay, suppose is 3.5 meter structure height, so you need to give here 3.5, and you can add here top of column, right? And say here S. And if you want to add some this apex, okay, so this is 800, so you can just create a one level here. So you can say here I want to add here 800. Okay, so this is my apex, and then you can just add here. I will just change the scale. Okay, and then you can just add here roof, right? So you can see we have added all the labels. Then your labels done, your grid lines done. Okay, so you need to start your modeling. So just go to your ground level plan. So this is the lowest plan, so you should start from here. Okay, so first of all, okay, so we have given here the base point also, right? Project point, so we have set here already. Okay, so you can't see here in ground level because previously we are in I think top up column, so you can see here. Okay, so once you set this, you can opt this. So how to opt? Just click, double click, sorry, VV. You need to go in model category and you need to opt this site. Okay, apply and okay. So let's start. So you need to find out your column size first. So if you go here, structural and column, and you can see here you see 200 203, but I don't want to use this. I will just or your size is not available in this list, so you need to go here, insert, load family, then you need to go structural column category and click here steel. Okay, so as for this AISC, so if you want to go here, so you can see there are different types of families here. So I want to add here structure column UC. Okay, so you need to go here in UC category. So it here HSS means hollow square section. Then okay, I will check one by one. So here is HP. This is the different category. Want to add the UC. This is the S shape. Okay, it's the W shape. Okay, so these are the, I think if you go again here, UC. Yeah. So generally we are universal just annotate universal column. So as per your standard, you can just suppose if you are working on Australian code or Australian standard, so you need to download as per the Australian standard library. Okay, so you can see here the PFC parallel. So PFC means parallel flange channel, means C channel. Okay, so you can see this is the PFC, and this is your UC, universal column, or UB, you can say universal beam. Okay, then this is your hollow rectangle HSS, right? Then your angle, equal angle, then unequal angle. Okay, so these are the different shapes, so you can take from here. So I will just add here. So this is the column category, so you need to go here in column category, and I will click here open. So you can see there are the different types of column sizes here, so you can pick. Suppose I have designed 305 by 305 by 240, so you all of you aware this, what is this? So this is the flange thickness, this is the web height, so all those things you can get here. Okay, so I want to export this 305 305 by 240 and click here, open. Right, so you could go here, structural, then click here, column. So you can see my size I have added here. So this is the UC, universal column. Okay, so I will use this size 305 305 240. Then you can add here. Right, so okay, so if I click here, but I want to change the orientation, so you need to select this. So you can see ground to top of column, it's automatically taken here, but I want to rotate this column. So you need to select, just select and press the space bar, so you can rotate in 360-degree. Okay, so my column orientation is like that because the rafter is connecting here. Okay, so if you look at in 3D view, so here uh, this looks like. So if you go to the realistic, so this is your column, right? Then once you add, so you can, so this is my main column. Okay, so what I do, I will copy this, add D here. Okay, and I will pick, I will select both the column, main column, and these main column is at my all grids. So I will copy this. Let's just select both the column and give the CO command. Okay, and you have option here multiple. So if you want to paste multiple, so just click here and you can just add then 3, then 4, like that. Okay, so this is the main column. Then you can add here wind column also. Okay, so wind column I have designed some uh, minimum, what we'll say, just different size. Wind column means I want to add here, because the if I add the roller shader here for supporting this, so I want to add the wind column here. Okay, so you need to go again, click insert, then library, load library, then I want to go here, UC, universal column, and click here. Okay, okay, so previously I have used 305 305 40. So I have designed for the wind column is 250 or 2054, or okay, so I will take this 203 203 and 86, or you can take any as per your requirement. Okay, so I will use this, and if you go again, structural column, so I will use this 203 203 86. So you can just add here. Okay, but the orientation it should be like that, because this is your major axis. Oops, like that. Okay, so if the raptor is coming here, so your connection it looks like. Okay, so this raptor is going in with slope. Okay, so I will use the same size for the raptor also, and this is your wind column. Okay, so this is your wind column, and this is your web here, like that. Okay, so if you see like that, so if I cut section from here, so it looks like. But if I cut section here, so how it looks, so this is I section, so this is your raptor. Then after that, what I do, I will just add a one plate. So it's, this plate is welded to the bottom of this I section in fabrication. Okay, and then after that, this wind column is coming up to like that. So this is the dotted line, and this is okay, and this is your web, it should be dotted. And then I will provide here two bolts. Okay, so these are connection I have not model, I will not model. So you need to create in 2D lines, because the reason, if you model each and everything, okay, small things, so your size is heavy, and if your model is heavy, so if other discipline is accept in their model, so it could be get the error. Okay, so we are trying to model only member. Okay, and all the connection we are creating in 2D. So I will explain in next session how to create this connection. Okay, but you need to know the method or methodology for this connection, so how it's work. Okay, so on the basis of that you need to model here. Okay, so what I do, okay, so I will copy this again, so the same size of column here, and I will copy this, put the column, give the co command, select, and okay, so this wind column is your only this first and last frame, we are not design here, right? Because we need to add some doors, and for this purpose we need to add the wind column here. Okay, so if I cut the section here, so how it looks your frame. Okay, so if you go to the view, so okay, I want to change the scale 51 s to 50. Yes, so you need to change this fine and hidden line, so you can see here, right? So you can see all the four column we have added here. So right now I want to add the Raptor. So before adding the Raptor, you need to fix the connection here, how to give the connection here. So suppose, so this is your column. Okay, and if you design this Raptor is coming like that. Okay, so if you design this portal frame as a portal frame, means this frame is in welded, fully welded frame. So if you design this, or if you design here, we need to add some plates, then cap plate, and then bolt connect to the Raptor. So it's depend on your design how to give. Okay, so before modeling you should know which connection where you need to give. Okay, so we just consider we have given this type of connection, or if you want to just cut here, so you can cut. Okay, so this column is just below, stop at the below this Raptor, bottom of the Raptor, and I want to add the cap plate here and just bolt here. So you can go with that. If you want to give the overhang, so you can go as per your requirement, but uh, no need to give the overhang. So because, or you can give, so is depend on your requirement which type of connection you want to give. Okay, so just go again here. So just consider we want to give the Raptor here, and this column is just stop below the Raptor. Okay, or you can give the overhang. Suppose if you want to give the overhang, so you can give the overhang, so 1 meter 500 or 300 mm. Okay, so just let's start. So first of all you need to add here, just add the center point of your building. Okay, so this is my center point, so I have just added your reference line, sorry, just this line as a reference. Okay, then you need to go here in plan. Okay, so I have designed the same size of Raptor as a column, because for connection, so mostly we are design the same size. Okay, it's for connection here. Okay, so I will go in now beam category, and I will use the same size. So if you select this, so 305, 305, 240. If you go to the beam category, so you can see there is no any as per this size. So you need to go insert, load family, and this time you need to go in beam category. So we haven't any special beam category here. You need to go here structural framing. Click here steel, and you need to search here UB, universal beam. So you can see here universal beam, right? And you have option here universal column in beam category. Got it? So this category you can use as a beam. Okay, so you need to click here, open, and you need to select your size 305, 305 for 240 UC as a beam category. You can see this is the beam. Okay, not a column, right? So just click here, and you need to go here and click here beam. So you can see structural framing and size is 305, 305 to 40 UC, right? And then you need to add here from this point to this point, right? And then you need to go in section, it looks like, but you need to give the slope here. So how to give? You need to go in plan and just select this beam and split it. Okay, split the element. So this, and you can split the element here. Okay, so if you go again section, it looks like. So if I select, so you can see this extension is 0 and this extension is also 0, right? So if I measure this gap, so di and this one, so this is 800, right? So you can just select this and you can add here 800. So your column is sloping like that. Then after that you need to give this connection. Okay, so suppose if you give some plate at the side, so you can give like that, or if your rafter is going here and you need to add the plate, so you can do that. Okay, so suppose this rafter is coming up to here. Okay, right there. Okay, so you need to cut this. So what I do, I will just add a reference line by 300 mm from the outer face of this column. This is my overhang, right? So this is my overhang. So you need to match this corner, right? And after that, you need to just add the RP command reference line at the bottom of this rafter. Okay, and just select this column and just cut you and select and cut. So you can see you can cut this, and up when we will given the detailing for this connection, so we can add the plate here in 2D line. So I will explain in briefly later. Okay, so you can see the same thing. Okay, so I will just do the undo. So what happened, our clear height is 3.5, so we can't disturb this. So what we'll do, I will move this rafter above like that. Okay, because I want to give the clear height is 3.5 for the column. So I will select this and just paste here, right? And after that, you can add the reference line. So we have add here reference line RP command and give here 300 x overhang here from this point to this point, and you can just match here like that. It's approximately okay. And then after that, you can just select this column and just increase your top 300 because I want to just give here because I want to break here. Okay, so you need to just adjust this rafter like that, and then I want to add your reference line at the bottom, right? And just you need to select and use this cut, select this column and like that. Okay, so you can see if I select this column, so column is trim here. Same thing, you can go here and you can add here 800. Oh, sorry. Okay, so I will delete this. So once you set your left side, so you can just select this and you can mirror and you can give the center of this building like that. Okay, then you need to give the connection here also. So this is my apex. So you need to just or like that, just intersect to each other. So you can see this is your apex points, intersection between two rafter. Okay, then you need to add the reference plane from here to here, and the same thing you need to select this and cut and select your reference line, then cut and select your reference line. So you can see we have put this rafter. The same thing here you can do. So I want to add the RP command. So reference plane, I want to set the offset 300 mm. up to here, right? So just extend, and I want to add the reference line in this direction also. So this is your extension point of your Raptor, like that. Oops, reference line is not parallel to Raptor. Okay, and you can just extend by 300 this column because I want to intersect with this Raptor for trim. Then you can give the reference line, then select this column and click here cut. So you need to select first column and then reference line. So you have added here. Okay, so you can see. Then after that, this wind column is also coming here. Okay, so you need to extend both the column up to here. So if I add here just the reference line, so my column is coming here. Okay, so column is up to here, but not just, you need to give some slot here. Okay, for installation. So I want to give here 10 mm gap. So I will just move this line by 10 mm below. So this is my top of column, wind column. Then you can calculate this distance. So what is the distance from this point to this point? So it's almost 500 mm. So I will just remove this reference line and just you can add here 500. So you can see the wind column is come here. Then after that you can add here 500. Okay, if you look at in 3D view, so it looks like, okay, so your Raptor is, your frame is done here. Okay, so once you done with, so you can just select this, okay, and just copy, right? So you need to just copy at all location, like that. If you copy, so this cut is not come here, so it disturbs, so you need to set here. I will explain in 3D. Okay, so you can see we have given the cut here, right? But if I paste here, so this cut not appear here, so you need to set at each location. So you can see this cut also is not come here. Okay, so we need to set here. So once you need to just move your section and go to your view, and you need to set at all locations. So you need to set here up to here, then this is okay. Then you can just give the command, or you can select, we have already added here reference line, so don't need to add it again and again. So just go here and use this cut, select Raptor and select reference line. So you need to go again here. In that case you need to extend your column by 300 because I want to cross to Raptor for the cutting. So just select your column and click here cut, select your column and select this reference line. Then same here, select and select. So at the third grid is done, move your, then next grid, then you need to do the same activity here. Cut, then here also cut. Okay, so I will select this, cut this Raptor and select this reference line. Then here also you need to extend up to here and select your column. Then you need to add here 300 mm and then you can cut 300 200. The purpose just or just cross your Raptor. Okay, then you need to just cut again column, then cut, sorry. Okay, so at the grid 2 is done and last is 1. So move your cursor, sorry, move your section and you can do the same here. Extend your column up to here. Then I want to add here 300. You can trim. Use the cut, then select and cut. Then select your column and select your reference line. Then the same thing, you need to cut your rafter. Okay, and we know the distance for this wind column 500. Previously we have calculated. You need to add here. Okay, so your frame is done at all location. You need to just save this. Okay, so this portal frame is done. So you need to design the horizontal member also for connecting the portal frame. Suppose I have designed here SHS size 100 by 100. So you need to just add your SHS from here, here, and here. Okay, so you need to go again and you need to go to the structural and beam. Sorry. So you need to go in plan. Okay, and go to the beam and you need to check the SHS size is available in your list. So not available. So you need to go in insert load family, and this time I want to search as a beam. Okay, so you can see structural framing, right? Then still, then you need to search here SHS. You can see hollow structural section. Then if I click here open, so these are the different size. So you need to click as per your requirement. So you can see here, oops, this is not SHS, is unequal size. No, yes, HSS 306, 306. Yeah, this is the rectangular HSS. Okay, so I will just click again load family and I will select HSS hollow structural section. Hollow structural section, yes, this one. So previously I have select the same one. Okay, you can see, you can check here also. RHS means rectangular hollow section. Okay, so I will select this HSS. Is there any other HSS family? SHS. Yeah, this one. Square hollow section. Okay, so you need to take this and click here, open. So you can see here. So this is the space perfect size. So you can see here 100 by 100 by. Okay, the thickness is if you go here, so to thickness is 10.8. Okay, so you can see it here, the thickness. So this is SHS 100 by 100 by 10. Okay, then yes, so okay, so you can take any as per your requirement. So I will just use this 100 by 100 by 8 here. Yeah, this is 6. Okay, so you can see here the thickness. Okay, so if you see this SHS, so this is your SHS. Okay, so this is 100, this is 100, and this thickness is 6 mm. Okay, so I will take this. You can see all this. Okay, and click here open. Okay, so if you go to the structural again and beam, so you can see the size is active here. Then you can add your, so your column is here at the center of this grid, and just add your beam. So if you look at in, or you need to set exactly in your sections. Okay, so I want to set here because I want to give, or you can give here also as per your requirement. So most of we are given here. Okay, rafter to rafter connection. So you need to find this gap here. What is the distance? Okay, so here, so right now I have added here top of column. Okay, so this is your top of the column, exactly place here. Okay, but if I select this, so you can see, so Z is top, right? So if you give the center, so it comes exactly at the center, right? Then you need to calculate this distance. If you want to add here, okay, so you need to give the offset here. So it's almost 207. Okay, so you need to add here you in your Z offset. Okay, so I will add here 208. So it comes here exactly here, right? Then if you want to add here one member here also, so just copy, and you need to just remove this constant. You can add one more column here, sorry, beam. You can go with the intersection, so you can add here. Okay, then exactly at the center, so you can add here also, right click and intersection. You can just remove this constraint like that. Okay, once you done, so you can just select and give the mirror command or the opposite direction like that. Okay, so if you look at in 3D view, it looks like right. Once you've done this, so you need to just select and you can just mirror or copy at all bay. Okay, so I have select this, so you can copy or mirror. So I will just copy and add at all location like that. Okay, so if you see, your structure is looks like so. This is your raptor, this is your column, wind column, right? So after, once you've done this, so if you see the section, so this is done. Then after that, horizontal, we need to horizontal add the horizontal supporting for this column also. If I design one member here, so I can add. Okay, so I want to add one more member here, so just measure this gap. So you need to just find out your center of this column here. So I want to add one more member here, so it's a 1955. Just you can just copy both and just give the co command, remove constraint, and just add here 1955. Okay, so if you look at in 3D view, it looks like. Okay, then you need to select this, go to your plan, and you can mirror or you can copy. So I will use the copy command and add at all bay like that. Okay, then if you go again in section, okay, so the main frame is ready. So we need to add here some Z purlin for rest. Okay, I will explain you in Paint. Okay, so new, don't save. Okay, so this is my Raptor. Okay, so I want to add some purlin here, Z purlin like that. Okay, so here is need to add the Z purlin, and then over that I want to add my sheet. Okay, metal sheet like that. Okay, so we need to add this light gauge Z purlins. So the criteria for this Z purlin is, suppose if your Raptor is going that, okay, like that. So if you want to add, see, this Z purlin, okay, so you need to give here at least 10 gap. Not, no need to rest this Z purlin exactly on the top of the Raptor. Okay, because in fabrication, here the top of the Raptor, we need to give the one plate here. Suppose this is 10 thick plate, so this plate is welded to the top of the Raptor in fabrication. Okay, so we need to give here 10 gap. So on site, when we will fit this Z purlin, so you can just add the 2 bolts. So this gap is 10 Then after that, the bottom of this Z purlin, you need to give here 35 minimum distance, 35 So and this is the 70 distance between 2 bolt, and again 35. So your plate size is approximately 35. So 1 bolt here and 1 bolt here. Okay, so and here welding. So this is your 45. Okay, because we have added the 10 here, and this is 75. sorry 70, and this is 35. So almost 145 height height of this plate. Okay, so if you use this 10 bolt, so your edge distance should be 1.5 times your bolt diameter. Okay, on the basis of that you need to calculate this. Okay, but if you model, so you should give the 10 gap between the top of the rafter and bottom of the purlin. Okay, so you need to add the purlin here. So the purlin also come in your beam category. Okay, so if you go to the plan and if you check here, so you need to find out any purlin. So no any purlin family here, so you need to load this. So go to the insert, click here load family. So we are need to go in structural framing, means beam category. Okay, then you have option here light gauge steel, right? So you just double click, you can see here light gauge steel. So this is C purlin, then this is the light gauge uh, puring channel. Then if you go down again, so you can see this is the joist. Yeah, so you can see light gauge purlin rail here, and this is the Z purlin. So or if you go to as per Indian style, Indian specific, so this is your C shape. Where is that? Okay, yeah, so Z with lip angle, and this is Z's. Okay, I want to add the C shape, so you can see the C purlin is also available here. I will check again here. L, yeah, this is the C purlin, right? And this is Z purlin. Okay, and this is also, this is different purlin rail. Okay, I will check this. So if I click here light gauge Z, click here open, so you can see the different types here. Okay, so as per your requirement, 172 means height, 202 is height. Okay, so this is, these are odd sizes. So I will check in again Indian specific size. So lip, I will check this Z purlin and click here open. Yes, so this is standard size, so 264 and 2. Okay, so these are the different dimension D, B, T. If you Google Z purlin, so you can see what is D, what is B, what is T. Okay, so suppose I want to add this Z 200 64 2.5. If I click here open, so it comes here. Okay, and then you need to just add just tentative here. We need to fix the location. So you need to go in your section, so you can see this purlin is looks like. Okay, then after that you need to fix here. Okay, so what is the criteria for this Z purlin? The criteria is you need to add from this point to this point, so maximum spacing is 1.2 meter center to center. Okay, so you need to find out first what is the distance from here to here. So this is 5545. So if you go to the calculator, okay, 5545 divided by 1.2 meter. Okay, so almost you need to add 4.6. So 5, just consider 5 number of purlin. So if I given 5545 divided by 5, so it's almost 1109 is my center to center. If I add 4, so it exceed my 1.2 meter. So you can go with that 1109. Okay, so you can just add the reference line. Okay, for this point to this point, it's perpendicular here, right? So first purlin will sit here, right? But you can't sit here because the connection is not getting proper here. So you need to give some gap here, so at least from the from this edge you can just give the 100 so just move your reference line by 100 so first purlin will be rest here. Okay, then you can calculate this distance. So if I give the di command, so it's almost 5387. So if I go 5385, just consider, and divided by 1.22 spacing, so 5 purlins we need to add here. So 5385 divided by 5, so it's almost 1077 spacing. Okay, if I go 5385 divided by 4, so it's exceed 134. Exceed is 1.2 meter, so you don't exceed 1.2 meter your purlin spacing. Okay, so go with that 5 number of purlin. So 5385 divided by 5, 1077. So you have already added here. So create a similar reference line and 1077 and just add your lines. So you need to fix first location of your Z purlin. Okay, so you can see we need to add the Z purlins here. Okay, but here you can't add the Z purlins. What is the reason? I will explain here. Okay, so this is your Raptor. Okay, and then I want to add some Z purlins like that. But here I don't, because I don't want to add the Z purlin. The reason is I want to add here C purlins. Okay, because at the end of this we need to add the gutter here for drainage the any, if in rainy season, so rainwater can come over the top of this roof and just come here. So if you add here Z purlin, so connection is not fit here. So I want to give the connection here, so I want to add here C purlin, and then my gutter is come here, and then you can just bolt here like that with this C purlin. Okay, so we need to add Z purlin at 1 2 3 4 and 6 location, not at the end. Okay, so I will just select this Z purlin and remove constraint here and disjoin, and you can add here. Okay, so I want to give the center exact, but your Z purlin, it should be parallel to your Raptor. Okay, so if you go here in annotate and just click here slope, spot slope. So if you check your spot slope for this Raptor is 9.37, so you need to select your Z purlin and you can add here in cross section 9.37. So yeah, so you need to just add minus, so you can see this purlin is perfectly parallel to the Raptor. Okay, so minus 9.37, then you can give the center point. So just move, and you need to pick the exact midpoint of your Z purlin and just match. Right click, go here, and you need to click here perpendicular. So you can just remove this constraint and paste. Okay, and you need to give the 10 gap here. So if I on this, oops, you can't see any lines. Okay, so you need to move this purlin and remove this constraint and here, and move by 10 up. Okay, so remove constraint again, or you can just add the reference line, so it's could be easy. Okay, and I will add, you need to add the reference line by 10 gap when you can add here. Okay, so you can see this Z purlin added here. If you look at in 3D view, so you can see this is your Z purlin. Okay, I want to just change it shaded so you can see clearly. Okay, like that. Okay, so once you done at one location, you can just simply copy here, give the co command and just copy at all location, perpendicular and you need to remove this constraint and perpendicular here. Then right click, snap override and perpendicular, like that. Right click, perpendicular, remove constraint. So once remove constraint means your ortho is unlocked, so you can see the ortho is locked here in this direction, so you should remove this. Then right click, then perpendicular, just add here, just okay. So I want to just copy this Z purlin by here. So what is the distance? 1077. So I will just copy and add here. Okay, but you need to convert into the C purlin. Okay, so but we don't have any C purlin, so you need to go in insert and go to your load family, and you can click here. And but you need to first, what is the size? Okay, 200 height, so you need to select as per that. Click here, open. So you have here option 200. Yes, so you can choose as per any, as per your requirement. So I will use this and click here, open. If I select this and give the two, like that. Okay, so you need to change the angle, so 9.37. So just select and you can just mirror this, remove this copy option and mirror. Okay, like that. And if I offset this line by 1077 here, and then you can, I will just delete this dimension, you can just uh, match like that. Okay, but you need to give the connection here. So how to give connection? We are not giving the connection here just by plate. Okay, so here is a different connection. Okay, and here is, here we can add the plate. If I give the plate here, so my gutter connection is not properly added here. So what I do, I will, okay, I will show you how the connection is there. Snap. Okay, I will, yes. So in that case, we can add the one angle here, equal angle, like that. Okay, like that. So this angle is welded to the top of the rafter, right? And you can give the some here plate, like that, and you can give the bolt here. So this connection is looks like that. Okay, and after that we can add the gutter here. So gutter connection you can just add like that. Okay, and then Z purlin, previously I have explained already. So this plate is welding to the top of the rafter. In foreign, in different, except India, in other regions, so these people are mostly welding process doing in fabrication, not on site. So because the site is very far from the city, okay, and the welding is not possible, so most of the welding part we are doing in fabrication, in site only, tie the structure. So they have no any option for welding at the site, so we need to give all the connection first, then they fabricate in fabrication, and just load the all structural member on truck, and just pass to the side and just tie. Okay, so the same thing I have select, I will select all those things, and the same here, use the mirror command and just select the center of this structure, so you can see. Okay, if you look at in 3D view, it looks like, okay, so framing is done here, right? Then after that you need to add the side purlins also. If you look at in section, okay, so we need to cover this area also. Okay, so you need to add the Z purlin or C purlin as per your requirement. If you design the Z purlin, you can go the Z purlin. Okay, then criteria is, if I add the reference plane, so first purlin side girds, it should be 100 mm below. So the plate is welding to the column here, and then your Z purlin is come here, Z or C, whatever you have designed. Okay, so before modeling you need to think the connection also. Okay, so suppose I want to give the C purlin here, like that. Okay, and so my plate is come here, like that. So in fabrication this plate is welding to the outside of this column, right? Then after that I want to this gap should be 10 mm. Okay, and then first bolt is your at 35. It's depend on your bolt diameter, and then 70 here, and then 35 here. Okay, 35. If I use the 12 mm dia, okay, so if you make it 12 into 1.5, so it goes up to 18. So 18 is minimum. Okay, so don't, you should give the more than 18. Okay, but for the bolt tightening, so you need to give some space here, because spine, what will say, spiner will rotate in 360 degrees, so you need to give the distance here. Okay, so if you use 16 mm bolt, so go to the 16 into 1.2, sorry 1.5, so you need to give minimum 25 mm edge distance. So this criteria, but we are giving 35, so 35 most of comfortable distance, edge distance. Okay, so you need to add the C purlin here. So if you have already, or if you uh, add Z purlin, so you can go with that. So Z purlin, it's, so this is your plate, right? And you can just add your Z purlin like that, and your plate will be come here. So if you design Z purlin, you can go with that, right? So I will just copy this and paste, and you need to set the 0. Okay, and I will add here 90 degree, so it comes here like that. Okay, so if I move this, remove the constraint, and this is my center. Okay, so you can just move. Okay, like that. So this is my center. What is the thickness? The 3 mm. So I want to move 1.5 below, like that. Okay, and your plate will be come here, but you 10 mm gap here, so just move by 10 mm, like that. Okay, then if you go down, so your sheet comes up to here, from this point to this point, right? So if I add the reference line, so if I cover this building, so my sheet come here, right, up to here, this part. So suppose my sheet size is 25 mm, so up to here 25 mm thick. Okay, so you need to add, you need to just increase your side gird size, this Z purlin, or you can just move here, and then you can just extend your plate size. So you don't, you have option, if you want to increase the size, or you can just move this purlin here. Okay, because your sheet is come here, and then, okay, I will explain in okay, so my sheet is come here, right, like that, and then I want to just add the screw here. Then in that case I want to make this plate is longer, like that. Then I want to add the bolt here, or you can just increase the size, like that. If you don't want to extend, or as per your design this plate is not fit as this distance, so you can extend or you can increase the size for Z side purlins. Okay, so you can just go again, then load family and click here open. So right now you have the maximum size is 350. So okay, I want to use this and just select, and 350 here. Okay, so you can just, so 350 is very big here, like that. Okay, okay, I will use again different size. Okay, so this is structural framing with lap angle. Go to the load family with lap angle, and yeah, so 203, 250 is maximum. 152, 152. Okay, I will use this 250. 228. Okay, 250. So if you go and just make it 250, yes, you can use this also. You have option if you want to extend your plate, so you can extend, or if you want to give the or increase the size for Z purlin, you can. So in that case you can add your plate, like that. Okay, then after that you need to give the, so this is your top of slab, so you can't give exactly at the corner here. Okay, so you need to add the reference line, and your plate should be 100 above the top of slab. So I will just move here 100 by here, so my plate is come here, right? So like that. So if I measure this distance, so it 3300. The same criteria, we are not exceeding the center to center between the side Z purlins is 1.2 meter. So if you calculate 3.3 divided by 100, so almost 3 purlin we need to add here. So 33 divided by 3, 1100. Okay, so you need to just copy 1100 mm. Okay, and just copy again. Okay, like that. Then we have already added here, so you can just copy, remove the constraint, just add. So copy, give the base point, remove constraint, and just add. Remove constraint, then remove constraint, like that. Okay, so you can see all the Z purlins is added here. If you look at in 3D view, it looks like. Okay, so once you're done at one side, you can just simply select and mirror. So you can give the mirror exactly at the middle of the structure here. Okay, so if you look at in 3D view, your structure looks like. Okay, then after that, shall we stop or shall we continue? 15 minutes. If you want to stop, so we can stop. Shall we continue or stop for 10 to 15 minutes? Hello?
Continue, sir.
Okay, okay, yeah. Okay, so the skeleton almost done for this building. So we need to add the roof here. Roof, what we'll say, sheet, metal deck sheet we can see. Then at the side girds also. Okay, so before adding, so we need to add this side girds in this direction also. Okay, because we need to add the sheet in this direction. Okay, so you need to add the sheet here also. Okay, so so location is fixed. Okay, so what we'll need to do, I will select any one. Okay, and mirror in 45 degree. So I have select already one Z Berlin, then use this mirror command, and then I will select the intersection between the grids and mirror in 45 degree. So what happened, my Berlin is mirror exactly at this location, so you can see. All right, then you can just set as per the location. So this Berlin is coming, oops, ground floor, yeah. So you need to change it, fine, and hidden lines. Okay, so this Berlin, it comes up to here, right? So you can just extend, use the extend command, select this and just extend. Okay, like that. Then the same thing, you want to, if you want to add the reference line from here to here, and then select, in this time you can use the trim command, like that. Okay, then you can extend this Berlin up to here. Okay, so use this command, extend, and you need to select like that, then select again and extend. Okay, and then after that you can give here some plate connection for connecting. So if you look at in 3D view, so it looks like okay, then you can just copy the same. So I have select, okay, okay, so you know the distance here. So I have select one and just copy and give the distance. So what is the distance here, center to center? So it's 1.2, no, okay. So I will select these all and go to the plan and just use the mirror command and select the intersection and just mirror in 45 degree. So if you look at, it comes all at all like that. Then you need to set all the purlins again. Okay, so this is ground floor and this is your roof floor. Okay, then after that you need to just extend. So okay, so if you go and top column here, okay, then you can use this extend, select your extend line and just select, then you can use the trim here. Okay, so use this, select your reference line, select your member, go again, select your reference line, then select your member, like that. If you look at in 3D view, it looks like so. Oops, one is remaining. Okay, so go to again roof plan, okay, here. Okay, so which one is, yes, so this one. Okay, or you can just use the align command also. So you just give the AL command and select this face and just align all the purlins. Give the AL command, select here also, give the AL command, select this face. I want to align up to here, this purlin, then align. Okay, like that. And you need to extend all this purlin up to here. So you have already one here. So select this face, this side face. Okay, and you can just tick here multiple and select all the purlins, like that, like that, like that. Okay, then here also, so you have already set one L, select the face of this and just select, then select, then select. Okay, then same here, we need to select this all, right, and you need to add here in front size. Okay, so you need to find the midpoint of this grid between the 1 and 4. So I will just add the line here. Okay, and select all purlins, go to your plan, use mirror command, and just add. Okay, like that, so you can see. Then you can just adjust this edges also. Okay, okay, so if you give the roller shutter opening, okay, so you need to trim this. Okay, so it's depend on your roller shutter size. So you need to just cut this and you need to give the opening. I will explain in tomorrow how to add this roller shutter. Okay, so skeleton is almost done. Then we need to add the roof here. Okay, so if you go to the roof floor, okay, you have create the skeleton, but you need to give the roof here. Okay, so if you go to the architectural, because in structural not possible the roof with slope. Okay, so you need to go in architectural, click here, roof by footprint. Okay, and then you need to select here. So what I do, I will select, create a new roof, duplicate, and you can give the name metal deck roof, and 25 thick. Okay, so you can give the name, then you can just change the thickness 25, click here. Okay, then you need to assign the material. Okay, so if you give material, you need to find any metal deck roof. So metal light gauge, so you have one, or metal deck you have. So if I select and click here apply, and okay, okay, so I have create this. So we know how to add the roof. So I will use this pick line, right, and my roof comes up to here, up to edge of the side guards. Okay, so I will select this line, then select this line, then select this, select, then this is the edge of the side guards, right, and this is the edge of the side guards. Okay, and I will just trim all the lines. Okay, and finish. Okay, and then if you look at in 3D view, there is roof. You need to on this roof category, apply and roof. Oops, your looks like. So if I convert into the realistic, so okay, so you can see. Okay, so we need to give the slope. Okay, so what is the slope? So we have slope here 9.37. So select your metal deck and go to the edit footprint, and then assign the slope for this two direction. Define slope, and what is the slope? 9.37, and here also 9.37, right, and click here OK. Let's see what happens. Go to the view. Okay, so it's not come exactly at the middle. Edit footprint, it's a 9, oops, not added properly, 9.37. And just check here 9.37. Okay, if you look at in section, so it looks like, so where is section? Okay, so you can see. So if I select, so this is the roof level, so he has exactly start on the roof, but you need to fix here. So how to fix? You should know this distance from the top of the purlin to the bottom of the roof. so it's almost 280. Okay, so select this and you can just add here minus 280 it on your roof, sorry, top of the purlin. So if you look at in 3D view, it looks like so. But the texture of this roof is not proper because we have one family, so your metal deck should be looks like so. Okay, like that. So we need to, because the rainwater is coming in this slot and just drain out. Okay, so this pattern is not right, but you can assign here, right? So if you have project already and the metal deck you have, so I will just check. We have, so yes, so Revit here. So I have one sample drawing, so I will try to open this. Yes, so you can see this is your metal deck. Okay, so what I do, I will just select this and copy and paste. Okay, so you can convert this, right? So close this file. Okay, so once you copy, so you can see this family is coming here. So this is the roof, and if I go to the edit, okay, so I will select this, and if you go here, so this family come here or this. Okay, so if I check and go to the edit type, so oh, so they have used the edit in place for the roof. Okay, but we can assign this material. So if I select, so you can see the material is cladding. Okay, so once you paste in your drawing or your file, so this material it comes in this file. So if I go here and go to the edit, and if I try to search the cladding, so you can see, yeah, so cladding is appear. So if I select and okay, so you can assign the same material here, you can see. So I will just delete this, so you can see, so ribs you can see here, right? So water, rain water is coming on this top and just drain out here. So it looks like so. Okay, so I think we should stop for now. So tomorrow we'll continue on the structure. So if you have any question, so you can ask. No question?
सर वो जेड पर्लिन में लिप एंगल क्या होता है?
लीप एंगल ये कैसा है, ये अगर हमारा साइट छोटा है, ठीक है, सो हम इसमें एक में ही कवर करेंगे, लेकिन हमारा जो अगर बिल्डिंग बड़ा है, तो उस केस में क्या करते हैं, ये मेरा एक जेड परलिन हो गया, फिर ये ऑल, तो ये जो एंगल रहता है, ये जो लैप रहता है, लिप एंगल, सो इसको लिप एंगल बोलते हैं। ये टाइप को, अगर आपका बिल्डिंग छोटा है तो ये कि इसमें कवर हो जाएगा, सो इसमें आप, सो ये दो अलग चीज है। सो इसमें ये हम बार कैसे लैप करते हैं, ये लैप रहता है ना यहाँ पे, सो ये केस में ये जेड परलिन और दूसरा जेड परलिन लैप होता है यहाँ पे, सो इसको लिप एंगल बोलते हैं। ठीक है, और स्लॉट रहता है।
ओके
ओके, सो आपने किसी ने किया है डिजाइन इंडस्ट्रियल बिल्डिंग, कॉलम टू राफ्टर कनेक्शन और अदर कनेक्शन, बीम टू बीम कनेक्शन? हेलो,
नो सर
अच्छा, अभी आप पढ़ रहे हैं क्या अभी मीन्स जॉब कर रहे हैं क्या पढ़ रहे हैं आप?
मैं तो अभी कंप्लीट कर रहा हूँ मेरा डिग्री।
अच्छा, ओके। सो इसका मतलब पर्पस क्या है कि ये जो कनेक्शन है, सो आप अवेयर होंगे ऐसा, ये एसएचएस क्या रहता है, पीएफसी क्या रहता है, यूनिवर्सल बीम क्या है, यूसी क्या है। सो इसमें ये जो डायमेंशन है वेब का, बीम का, फ्लैंज का, देन वेब का थिकनेस वगैरह, सो ये यू आर ऑल ऑफ यू अवेयर ऑफ दैट, राइट?
यस सर,
ओके,
चलो स्पीड टेबल में होता है वो।
यस यस, परफेक्ट, यस। सो मुझे क्या लगा
बस उसमें
कि
वो लीप एंगल का नहीं पड़ा था, इसलिए मैंने पूछा
नहीं
एक
नहीं
बार।
नहीं 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 नहीं, वो लिप एंगल का ठीक है, नहीं, वो तो अलग ही है, वो कंसेप्ट से अलग है। नहीं, मेरा पर्पस क्या है कि मैं यहाँ से जब इंसर्ट करता हूँ तो आपको सारी चीजें पता है ऐसा। लिप एंगल का, ये तो लिप एंगल डिफरेंट है, ये भी आपने पहली बार भी सुना होगा वो, उसके बारे में नहीं। लेकिन जब मैं ये साइज वगैरह जब इंसर्ट करता हूँ तो उसमें आपको कौन सी साइज लेना है उस हिसाब से आप वहां पे जा सकते हैं, बराबर है। तो पर्पस फॉर आस्किंग for that, not for leaf angle, right?
यस।
Okay, so let's tomorrow's session is on 7:30 tomorrow. Okay, so just do the practice. So question, doubts, no question. Okay, good night all. See you tomorrow.
Good night, sir.
Good night.
Good night. Okay, sir.
Good night.
Good night.
Good night.